Hello, everybody. Today we're going to be talking about volume, and specifically the volume of a cylinder, of a cone, or of a sphere. So there's three types of objects that we want to take a volume of in eighth grade, and cylinder is where we're going to start. Then there's going to be cone and sphere, and all of these different objects all have something in common, which is they use a circle in their measurements. Okay, different sides of a cylinder or cone have circles, and a sphere is just a three-dimensional circle. So what we're going to be doing is I'm going to look at the different volume formulas for each of these. They're all a little bit different, pretty similar, but a little different for each one. And I'm going to show you where to plug in those numbers to find out your answers. So if I start with a cylinder, I'm going to get usually a picture like this. Sometimes they might draw this cylinder vertical, so it's kind of straight up and down instead of left and right, like a horizontal. And sometimes they give you different measurements here and different, definitely diameters or radiuses. So for a volume of a cylinder, here it comes. The formula for this is pi r squared h. Volume equals pi r squared h. So pi is going to be in each of these. R and h are what the two numbers that we need to find. So we need to find two different numbers from our picture to plug in here. And if you see, we have two numbers, so we just got to plug them into the right spot. So the height is going to be this side here, this 19 feet. Okay, if it's on its side or if it's straight up and down, it's still going to be the height. Okay, so that's going to go in for h. 2 feet over here, this is the radius. Radius is from the center of the circle to the edge of the circle. Okay, so if you have a radius that's 2 feet, okay, this distance here, 2 feet long, that'll go in for the letter R. Now sometimes, let's see if I can do it again, and they'll give me another one. Yes, sometimes they'll do this to you. They won't give you the radius, they'll give you the diameter. Okay, so the radius starts with an R, which is why our equation has an R in it. It does not have a D. Okay, D is for diameter, so that means that we have to cut this in half. The diameter goes all the way through. Radius, we just want from half of that. So we need to cut this in half. And if you see on the problem they did 6 divided by 2 is 3 feet, and 3 went into their formula for R. 30 feet was the height, so that came here for h. And now r became 3, h became 30. Now they use 3.14 for pi, which is a little bit of an estimation, but at the end they want you to round to the nearest whole number anyway. So it's okay to use 3.14. If we had our graphing calculators in school, we can use the pi button on there and make it even more accurate. So if we have pi times 3 squared times 30, we can start by using pi as 3.14, and we can plug this all into a calculator and multiply all this out. 3 squared is 9, so we'd have 3.14 times 9 times 30, which should give us this, 847.8. Okay, I'm going to use a graphing calculator most times when I do these problems, but I don't always have a graphing calculator with me, okay, especially when I'm here at home. Okay, so what I can do is use this problem on Desmos. So what I'll do is I'll take, okay, I got 6 feet and 27. Well, 6 feet, that's the diameter, so I need half of that, so I'm going to use 3 and 27. And I'm going to open up and go to Desmos, and I can start graphing. Now, I don't need to graph anything, but over here on the side, it uses this as a graphing calculator anyway. Okay, so there's different options I can use here. And, let me do this. So if I put in my volume formula, okay, and if I use Desmos, which I'm going to show you why it's a little bit helpful. So what I'm going to do is I need 3.14, and I can use this little calculator button here to bring this up, and I can say 3.14 times my radius is 3, and I can use a squared to make this number squared, and then it's also times my height, which I think was 27, but I'm going to double check before I go any further. Yep. So now I have 3.14 times 3 squared times 27. And it gives me my answer here. It has a little equal sign and my answer. So 763.02. If I go back to this and check on my explanation, should have the same number here. 763.02, rounded it up to 763. Okay, so what I did before this video started is I made a couple different Desmos tabs here for all the 3 volumes I'm going to do. But if I go to Desmos, I can keep it just like this. And then when I go to the next problem, if it's still a cylinder, I'll just come in here and say, oh, it's not a 3 anymore. Now it needs to be a 5. And it'll change my formula. Oh, it's not 27, it's 25. Or it's 23. Or it's 237. I can edit this and I don't have to keep rewriting it, or keep typing it into a calculator over and over and over again. Desmos will save it, and you can just keep coming back to this tab, go from Alex back to Desmos, and keep typing that in. So I'm going to leave this one and go to my cylinder one here. Okay, so I have this problem, volume equals pi r squared h, and I can just come underneath it and rewrite the same thing. I can write 3.14. Oh, I didn't get all those. Let me see. 3.14 times 3 squared times 27. And I'll get my answer. So now I'm going to go try some of the cone problems. Let's go back to this. Let's grab a problem about a cone. Now, what's special about a cone is that it has this circle on the bottom and it comes together at this point at the top. So my height now, my letter H is going to be 6 and my radius is 4. But what's nice about cones is that they actually have the same volume formula as a cylinder, but with one small detail. So they both have pi r squared h, which is just like the same things we were looking for from our cylinder. So I just paused it while I wrote these. This is the volume for a cylinder. This is the volume for a cone, but we're going to add one thing, and it's going to add this fraction at the beginning, 1/3. So what this means is a cone is 1/3 the volume of a cylinder. If you take a cylinder with these same dimensions, a cone will be the same volume, just 1/3 of it. So 3 cones fit into the same cylinder. As long as their height's the same and the radius is the same, then you can put 3 of these cones together to make one cylinder. So now let's see, we have 6 yards, 4 yards. So 6 is going to be my height, 4 is going to be my radius. So I'm not going to do that math by hand. I'm going to go over here to my Desmos with cones. So I'm going to type in my formula just like I would with any of these objects, and I wrote it down here ahead so I wouldn't forget it. So 1/3, so I'm going to do 1 divided by 3, and then I'm going to come to, let's see, pi, so that's going to be 3.14, and then, oh, I didn't put my multiplication sign. Probably still wouldn't have done it either way, but I like to put it. And now my radius, that was 6 or 4? Well, let's double check. 4. 6 was the height. So now I'm going to do 4, and I'm going to put a squared, so it squares 4. Then multiply it by my height, 6. And I have 100.48, and 4 is not big enough to round the 100 up, so it should just be 100. Let's go back. I'm going to check my work. Always like to check it if I don't forget during my videos. So is this one they do not want us to round? Use it and do not do any rounding on this one. Okay, well, there we go. 100.48. Don't have to round at all. Okay, so now let's go to another problem with a sphere. So a sphere, the formula is going to look similar, but it doesn't match with the cone and cylinder. Those two kind of match together, and one is 1/3 of the other one. This one is going to kind of take bits of each. So for a circle, we have 2 dimensions, but a sphere is 3 dimensions. So the volume for a sphere is going to be, we're going to have a fraction like we had for a cone, but we're not going to have a height. Okay, we're going to take the radius. The radius comes from the center all the way up to the edge. Okay, and this one gives us the diameter, which is 14.2. So we would need half of that. So half of 14.2, let's see, times, oops, can I erase that? Nope. Dang it. X. Don't worry about that little scribble, that little blob. 14.2 times 1/2 will give me 7.1. So that's what I'll use for my radius. That equals R. So for the volume formula for a sphere, it's going to be the fraction 4/3 times, oh, my pie is going to look a little funky. Oh man, I'm sorry, sphere. You got a lot of bad drawing on this one. And it's not going to be R squared, it's going to be R cubed. So for those other ones, we're multiplying by R squared and H. So that's R, R again, and H. R times H. That's three things that we need to multiply for because we're in the third dimension, three different measurements. But for this one, we only have the radius. We don't have a height, okay? So that means we're going to multiply radius 1, 2, 3 times. Radius times radius times radius. So we're going to use 7.1 for the radius. And this formula is a little bit nicer because you only have one number to plug in. You don't have to keep plugging in two different numbers. It's only one. So now I'm going to use my formula, 4 divided by 3, and times pi is going to be 3.14, and times R cubed, which we said was 7.1 squared. I forgot this multiplication sign, but we can look at the answer, see if it changed at all. No, it didn't change when I put it in. So if you forget it, like I've done sometimes, it'll be okay. So now we have 211.049866666. Let's see if they want us to round before we go any further. Let's see, nearest tenth. Okay, so let's go back to decimals nearest tenth. Well, tenths would be this 0 right here. So does the 4 round the 0 up? No, so it'll just be 211.0 or just 211 by itself. Let's see how they write it. 14, wait, is that what we got? Oh, I just realized my problem. Did you guys realize it? Maybe you watching the video realized it a lot sooner than I did. So my formula has a cubed here as 3, not a 2. I put 2 as my exponent. That was my old exponent. I don't want that. I want to come up here. I want to make it a 3. So let me do this differently again. So if I typed in 7.1, I need to hit A to the B. B just makes it blank. Okay, and you get to put whatever number you want there. Okay, usually 2 is used so often that they made a button for it. But if you have any other number you want to put as the exponent, you can use this one, A to the B, put the 3 there. So now I have 1498.4, and the 5 should round to where now my answer can be 1498.5. That makes more sense. All right. So for a sphere, make sure they're using the correct exponent. Otherwise, you get the problem wrong like I did. Okay, so we'll make sure we're using 3 there. All right, and just real quick, feel free to come back to the different spots in this video and double check what the formulas were for the volume of cylinder, cones, and spheres. Cylinder was pi r squared h. Cone was 1/3 pi r squared h. And sphere, 4/3 pi r cubed, r to the third. Okay, don't forget that 3 like I did. You'll look silly just like me.